Hello all. Today let us learn about catenation. Let's start with the definition. The property of self-combination of carbon atoms to form long chains or even branched and also cyclic compounds is defined as catenation. So here you can look at the first type of carbon compounds wherein carbon has formed a single bond with another carbon atom in a straight line. So these we call it as linear carbon compounds. Okay. So in linear carbon compounds what mainly happens is carbon undergoes self-linking with itself, and that is with the other carbon atoms in a to form a long chain, so that is called as linear carbon compounds. Also, catenation can be observed in branched carbon compounds. So now when you look at this carbon, okay, so here it is C, if I number it, C1, C2, C3 and C4. At C, look at carbon 2. At carbon 2 there is a isopropyl branch chain. Okay, so that's a substituent. So now here we can observe that this is an example for branched carbon compounds, because at C2 there is a further branching of the carbon compound. So hence again this can be an example for catenation. But here what we have to focus is that C2 is again formed a single bond with another carbon atom to form a branched carbon. And also catenation can also give rise to ring structure. So here there is an cyclopropane ring, and there are methyl groups as the substituent, at two methyl groups as the substituent on each carbon atom. So there are 10 methyl groups together, and this is again another example for catenation wherein carbon has formed another bond with carbon. So again this is nothing but self-linking. Now we have to understand that out of 118 elements in periodic table, carbon has been given the highest priority, or it has gained the highest priority with respect to catenation, and no other element has this ability or property, a versatile nature, to attain the catenation. So now let us understand the reasons for catenation. Why catenation is adversely seen in carbon? Carbon-carbon bonds are very strong and hence stable. This gives a large number of compounds with many carbon atoms linked to each other. So now carbon and carbon-carbon single bonds, they are highly stable because they are mainly they are very strong. So now we should understand why is it that carbon-carbon bonds are very strong. See, when we look at the periodic table, so carbon belongs to group 14, and when we look at the periodic table, so we have group 14, and in group 14 the first element is carbon and the second element is of course silicon and so on, and then we have germanium and so on. So now when it comes to carbon, carbon is having an atomic number 6. So when we talk about atomic number of carbon being 6, we should understand that as we move down the group in the periodic table, the size of the atom goes on increasing. So in that case, silicon is having a higher atomic size compared to carbon. Now because carbon atomic size is very small, it also means that carbon-carbon bonds will be very strong, because the nucleus of one carbon can easily hold on to the electrons of the second carbon, and vice versa. That is, carbon 2 nucleus can hold on to the electrons of carbon 1. So this creates a great strength in the bond between two carbons, that is adjacent carbon, and this is the reason why catenation is adversely seen in carbon atoms. And the second reason is tetravalency. We all know that the valency of carbon, so carbon is a non-metal and the valency of carbon is 4. So carbon being non-metal, the valency of carbon is 4, which means that carbon can form 4 bonds around itself with other carbon atoms or with any other monovalent element also. So in case we talk about valency of carbon to be, we're talking about valency of carbon to be 4, and when we say that carbon can form four bonds with other carbon. So this is again the reason why catenation can be seen in carbon, because the number of bonds or the valency of carbon is 4. That means that it is giving rise to 4 new bonds around each carbon atom. So in that way, students, when we look at the building of the carbon element, or sorry, building of the carbon bond and its strength, it goes on increasing. So that is why the new branch of chemistry called as polymerization came into existence few years ago, wherein the monomers of carbon go on adding up to give rise to polymers, and hence they're called as polymerization. So polymerization mainly is a branch of science of chemistry which mainly involves in the plastics and the polymers, and also the synthetic fibers that we are making use in today's life. So this is the reason why carbon can bond with hydrogen, oxygen, sulfur, nitrogen, chlorine, and so on. So these two reasons are the um, these two are reasons are the perfect answer for the question for why catenation is adversely seen in carbon. So in most of the 10th standard question paper, they are usually asking this type of question: why carbon is not, why silicon does not undergo catenation. Silicon also undergoes catenation, but to a maximum extent of 4 to 8 silicon atoms only they can bind. That's because, as I already mentioned, silicon is having larger atomic size. But when we talk about carbon, the size of atom is extremely small, and that's the reason why it can have self-linking to a very large extent. So it can go up to 40, 50 carbon atoms also can be self-linked. So this is the answer. Thank you very much.